we're going to be working with what's my rule. So I'm going to give you an input value. You're going to give me an input value, and I will give you an output value. Okay? When you have figured out the rule, I want you to go ahead and give me a thumbs up, or go ahead and signal to me what the output number would be. So could someone start us off with an input? Haley?
7.
7. Okay, so input 7. The output number would be 21. Michael?
2.
2. So the output number would be 6. Natalie?
4.
4. The output value will be 12. Eli?
5.
5. The output would be 15. Go ahead and talk to your shoulder partner about what you think the rule is.
Yeah. That times 3.
Because 7 times 3 is 21.
Okay, does someone want to share out what they think the rule is? Now I'm going to ask that you hold back from sharing it in algebraic terms. Let's just use words. A verbal representation. What would we say our rule was? Junior?
Times 3.
Times 3. Okay. Someone else have a different way to say that? Eli?
Multiply by 3.
Multiply by 3. Oops. Another way to say that? What about an algebraic expression? Vanessa Q?
Y equals x3.
Y equals x3.
No.
Could someone help us? Alexander?
Y equals 3x.
Y equals 3x. Now, x times 3 is the same as 3 times x, right? So we're going to just rewrite it the way it's more commonly seen with the coefficient and then the variable. Okay, so now we're going to go ahead and move on to a different rule. Okay, and this time I'm going to have you work within these constraints. The independent variable has to be less than or equal to 6 or greater than or equal to 0. So those are our constraints. Okay? So could someone start us off by giving us an independent value and input? Joseph?
4.
4. So if you put in a 4, you're going to get so the independent variable is 4 and the dependent variable is 15. Someone else want to give a value, an input value? Basil?
2.
2. So if you put in a 2, you're going to get a 7. It's another number we could try. Joseph?
3.
3. Put in a 3, we're going to get a 10. Thumbs up if you know the rule. Finger to the side if you'd be able to explain it. Okay, why don't you talk to your shoulder partner about what you think the rule is?
Times 3 plus 1 because 2 plus 6 plus 1 is 7. And then 3, 6, 9 plus 1 is 2.
Y is
Times 3
plus 1. Oh yeah. Yes.
times 2 plus
Yeah. Really?
6, 9.
Okay. Before we shout the rule, I have a question for you. When did you know, or when did you figure out the rule? Go ahead and think about that for a moment. When did you figure out the rule? Or was there a specific number that was tried that helped you figure out the rule? Would someone be willing to share their thinking about when they figured out the rule and how they figured it out? So I see a few hands, we'll call on a few of you. Eli?
I noticed it on the 3 common tens because I knew 3 times 3 was 9. So if you added one more, it'd get 10.
Okay. Someone else want to share out their thinking? Junior?
I figured it out in the second one because I remember you doing this, like, I think it was actually 2.
Okay, so you recalled something we did previously? Haley?
I figured it out on the first one because I was trying to figure out what times 4 equals 13, and I knew that 4 times 3 is 12, and plus 1 is 13.
Okay. Are there any other input values that we could test that would give us a lot of information about the output? So another value out there. Michael?
5.
5. Now, why would 5 be helpful for you?
Because it's easy to count by.
It's easy to count by? Okay, so that would be... Is there another input value that we might need to, what we could try that might give us some other information? Basil?
Never mind.
Never mind, okay. Haley?
1.
1. So put in a 1, we're going to get a 4. Any other inputs that would be able to give you a lot of information? Natalie?
0.
0. Put in a 0. What number am I going to get? Go ahead and just say it out loud.
3.
Oh, I'm hearing different numbers.
1.
1. What's 0 times 3?
0.
Plus 1?
1.
Okay. So if I take those points and then I graph them, or draw my line through them, let's start looking at the points on the line. What can we tell? What can we pull out of the line? What is some information that we can pull out of the line? Now that we've graphed it, we've plotted our points. We can compare the points. So when we compare the points, what's some information that we can pull out of the line? The graph. Zora?
We can find out that the rise could be, is 3 and the run is 1.
Now, can you tell me which 2 points you picked to compare?
310 and 27.
310 and 27. Let me use a different color. Okay, when you compared that, you counted and you got a 3 for your rise and a 1 for your run. Okay. Lily, what were you going to share?
I was going to share that for like each number you go up, like the input, like 0, then 1, and then 2, and then 3. The rise will always be 3.
The rise will always be 3? Okay. Now, Lily, can we dig a little bit deeper with that? What if I compare 1, 4, the ordered pair of 1, 4, to 5, 16? What's my rise going to be? Let's count.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
So my rise here is 12. What's my run?
1, 2, 3, 4.
So my run is 4. And we know that the ratio between rise and run is slope. What is 12 divided by 4?
3.
Okay. What's my equation going to be? What's my rule for this? What's my rule for this? Thumbs up when you have the rule.
Yeah.
Here's the side rule to share. Basil?
Times 3 plus 1.
Okay, so you said times 3 plus 1. So another way to say this rule? Adam?
Multiply 3 out of 1.
Multiply by 3, add 1. Alexandra?
3x plus 1.
3x plus 1. And what does 3x plus 1 equal?
1.
So this is the independent variable, and we have our constant, thank you, and then we have our dependent variable. So let's go back over here. Y equals 3x plus 1. Now in our line, we saw that we had a slope of 3, which we see in our equation. Is there anything else that we can see from our line? Alexandra?
It's a positive line.
It's a positive line. And how did you decide that it's positive?
Well, if you look at it from left to right, it's going upwards.
Okay, so then it has a positive slope. Okay. Michael, what were you going to share?
I was going to say the same thing.
Which is?
It was a positive line.
Okay. And how did you know it's a positive line?
because it's left to right, it's going upwards.
Okay. Any other observations? Zoro?
+1 from the occupied, yeah. It's similar to the graph because the line starts at 1, not 0.
So it doesn't pass through the origin, it passes through 1, positive 1 of the y-axis. Okay. Alrighty. We're done with our number talk for now, and I'm going to go get you the white handout. Thank you.